right, good evening, Bearcats. This is Precal, Pre-AP, the extra practice problem for Unit 3 test. This kind of goes over a lot of the different things that you'll have to be doing. Obviously, you need to know how to do long division, synthetic division. You need to be given roots or solutions, be able to write the factored form and multiply them back together to get your original polynomial. You need to be reminded that complex numbers and imaginary numbers come in conjugate pairs. So if you have a square root of 3 as a solution, you also have the negative square root of 3. Or if you have 2i, you also have negative 2i. Or if you have 3 plus 2i, you also have 3 minus 2i. So just making sure that you're clear with all of that. All right, so this is just the practice problem we're going to do. This is going to take us through synthetic division. It's going to take us through Descartes' chart. It's going to take us through factoring and solutions. We are going to, first, we're going to find all the possible, and that word possible is important, positive real roots. All right, possible means that we're not doing anything yet to find actual. We're just estimating not estimating, but we're finding our possible real roots. Possible real roots, the number of possible real roots is going to come from our Descartes chart. So remember, for Descartes chart, we have positive, negative, complex, imaginary, and total. You don't always have the total, but Ms. Lauren loves to write the total. I know our total possible roots here are 4. And we know we're going to have at least 2 rows. We might have more. So let's take a look. Positive means we're just going to have positive values in for all our x's. That means each term will hold its sign. So this is positive, 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 positive. No changes happening. So our possible positive real roots are 0 at this point. If we're filling in the chart, it'd be 0, 0. If it's 1, it's 1, and anything else reduces by 2. All right, so then we're going to plug in our f of negative x to find our number of possible negative real roots. All right, so when we do this, let's plug in. We get a negative x here. We take it to the 4th power. It's positive times positive 2. We get a positive result. Take a negative here, cube it. We get a negative times a positive. We get a negative result. Here we take a positive, we square it, is positive times positive is a positive result. Here negative times positive is negative, and of course our constant will hold at a positive. So if we're plugging in this is what I'm looking for on a test. And then let's count the number of sign changes. Positive to negative is 1, back to positive 2, back to negative 3, back to positive 4. So the number of possible negative real roots is 4. Also it could be 2. Also it could be 0. In our chart, that would be 4, 2, 0. We have to add a 3rd line to our chart. We were talking about the complex imaginary. This would be 0. They all have to total to 2. This would be 2, and this would be 4. So we're either going to have 4 negatives, no complex, 2 negatives, 2 complex, 0 negatives, 4 complex, all adding up to 4. We know we're not going to have any positive results. All right, the next thing I want us to find are all possible real roots. All possible real roots. That's your P's and Q's, positive and negative values of the factors of P over the factors of Q. Our P is 2, so that would be factors of 2, which would be 1 and 2, positive and negatives, over the factors of Q, and in this case that's 2, positive or negative 1 and 2. So it would be positive and negative values of 1 over 1, 1 over 2, and 2 over 1, and 2 over 2, which is also 1. So those are our possibles. Now, if you're really paying attention and found out we didn't have any positives, then really this would reduce down to only the negative values of 1, negative 1/2, and negative 2. And I would really like for you to show that to me if that were the case in your problem, which it may or may not be. So now we have our possible real roots. We have our equation. We're going to use our possible real roots, and we're only going to use the negatives because of our chart. And we're going to start synthetically dividing to reduce this polynomial from a 4th degree down to a quadratic so we can find our last 2 solutions by another method. So let's use synthetic division first. And we're only going to use the synthetically divide off of our list. So we're going to do 2, 5, 4, 5, 2. And there's several little formats to set this up. I'm just going to set this up in a chart like this. I know I'm going to be using these values until I find a 0. So I'm just going to go and start with -1. I always bring down the 2, or the first term just comes straight down. 2 times -1 is -2. -2 and 5 would be +3. So 3 times -1 would be -3, and 4 would be +1. 1 times that would be -1. -1 and 5 would be +4. And -4 and 2 would be -2. All right, that gives us an ordered pair -2, -1, -2, but it does not give us a 0. I like to make a little sketch because it helps me find my zeros a little quicker. What do I know about this problem? I know I have a point on the graph at 1, -2. I also know I have a y-intercept at +2. So I know I'm going to probably cross somewhere between there. So I'm guessing I'm going to cross at -1/2. So let's try that next. Keeping using these values, since I have not found a 0 yet, I'm going to go ahead and put in -1/2. But I'm using these numbers at the top. So bring down the 2. 2 times -1/2 is -1. -1 and 5 would be 4. 4 times -1/2 would be -2, and 4 would be 2. 2 times -1/2 is -1, and 5 would be 4. And 2 times -1/2 times -1/2 times 4 is -2, and 2 is a 0. Happy day. Go Bearcats. All right. So we know we have a 0. In a minute, I'm going to need the factors. We know we have a 0 at 1/2, so my factor would be x plus 1/2. Or if you'd prefer to write it as 2x plus 1, either way would be fine. We know we have a 0 at 1/2, -1/2. And we know that this graph turns up on the right and up on the left. So we've coming down. We know the graph has to go back up on the right. So maybe I am going to have -2 as a 0. Well, I'm going to use my new values now, since I found a 0, to synthetically divide, because now I'm in a 3rd degree polynomial, and I'm going to use -2. All right, let's keep going. So bring down this 2. 2 times -2 is -4. -4 and 4 is 0. 0 times -2 is 0, and 2 would be 2. 2 times -2 is -4, and 4 would be 0. Hallelujah, we find another one. Go Bearcats. All right, so we have a 0 at -2. Let's go back up to our little graph. And we have a factor then at x plus 2. We have solutions so far at -1/2 and -2. But we know we have to have 4 solutions. So we have found 2 negatives off of our list. So either they're going to occur twice and cause a bounce in our graph, or we have 2 complex imaginary. But remember, I've gone from a 4th degree to a 3rd degree, and now finding another 0, I'm at a 2nd degree or a quadratic. I'm using quadratic formula or properties of quadratics now to solve this. So this would be a 2x squared plus 2, since there's no x value in the middle, 0, equals 0. Well, this one we can just solve by square root property. So we'd move the 2 over, and we would get 2x squared equals -2. We would divide by 2 and get x squared equals -1. We're going to take a square root of a negative number. They're going to be imaginary. So back to our chart. Our chart then will say that we will end up in this part of our chart. 0 positives, 2 negatives, and 2 complex imaginary for our total. So our graph would look like this. Let's keep going. And we would have x equals positive or negative. Square root of -1 is just I. So positive or negative I. If we're writing the factors, we would have to write, this is a positive I and a negative I. So we would have x minus I and x plus I. Those are our factors. And for our solutions, we would have, you could just write as plus or minus I. There are our 4 solutions. There are our 4 factors. There's our Descartes chart. The chart yields this information. Sketch the graph helps us. And hopefully that will help you a lot. So good luck tomorrow, and go BEARKATS. Go Bearcats. Have a great evening.